hundreds of people need to have this to defend yourself.
Can I get a proper hammer?
Well, no, because you need to wish them luck, not death. Okay, so let's get the talk started.
Right.
Put your hands together for Tomer. And let's do some refactoring.
All right, so first things first, this talk is aimed for somewhere between beginners and sort of intermediate users. So you're expected to know a bit of Scala, you're not, but if you're sort of an advanced user, this may be a little bit, trivial for you. If that is the case, feel free to get up and leave. I will not be offended or anything. Also, if there are any questions or comments, either shout them out or raise your hand. I'll repeat it for the camera if necessary. This is supposed to be useful and potentially fun. I'm not guaranteeing any fun. But, if you have anything to add, just interject. So, my name is Tomer Gabel. I work for an Israeli company called Wix. And for the next 40 minutes or so, what we're going to be doing is we're basically going to be dissecting a live code base that I did not myself create. And we're going to have a look at some examples of what I consider to be subpar or difficult to reason about Scala code. Look at a few examples, talk about like what is wrong, what is right, and showcase a few techniques on how to make it better. The victim in this case is a library called Scala Chess. It's open source. It provides a domain model for the game of chess. Which I assume that even if you don't necessarily play, you're at least a little bit familiar with. The library was chosen because it has a pretty decent test coverage. It's a long-lived library. It's been around for, I think, 5 or 6 years. It actually drives an online chess-playing website called lichess.org. The quality of the code is, as you might expect from a long-lived library, so it's a little bit all over the place, but it's generally pretty solid. The license is open source, so it's kind of a good candidate for showcasing what a beginner getting into a new Scala code base might experience, I hope. So with that, we're gonna start off with just a bit of a warm-up, okay? Just to give you an idea of what it is we're gonna be talking about. There's basically 3 sections to this talk, or 3 different aspects that I'm going to be focusing on. Obviously, there is an endless wealth of things to refactor and refactoring techniques, so this is not going to be comprehensive by any means. It's just going to be, hopefully, a little bit instructive and useful. So just a quick warm-up that is not particularly complicated. As you know, the 2, as Conrad also explained in his keynote, the 2 difficult problems in computer science are cache invalidation, naming things, and off by 1 errors. So we're going to be focusing on naming things because what's a little bit unusual about Scala is it adds a number of features that make this a bigger problem than in many other languages. So if you're coming from more of a traditional enterprise-style Java background, you may be used to crazy names like proxy, abstract, singleton, factory, thing. Which doesn't really mean much. In Scala, because the code is a lot more dense and there's more features, generally picking good names for things ends up being more important. So to give an example, here is a little bit of code. So we have here our case class called Geo. Can you actually see this properly in the back? Cool. If at any point it's not visible or you want me to increase the font size or whatnot, just shout at me. So as with any kind of geo-coordinate system, there's latitude and longitude, and there's this helper function called distance right here that gives you the distance to a target point and as a double. The units don't matter, that is not the point. And you can see that we have a center and a location. Both of them are of the type geo. And we want to say that if the distance between the center of a circle and a particular location is within the radius of that circle, we will return it, otherwise we'll return none. So this is really trivial code. The thing about Scala is that it adds infix notation, or as some people like to call it, dot-free notation. which means if you eliminate the dots and the parentheses, suddenly you have this if center distance location, which is actually not too bad, but it's not in any language you might speak, right? I mean, it's supposed to look a little bit like English sentences, but it kind of isn't. So this is a really trivial kind of thing, and it's pretty trivial to fix. If you have this, just, call it distance to or distance from or whatever you're comfortable with, problem solved, right? So this is not a problem you have in most other languages because you don't have this ability to use methods in two separate ways. So this is a little bit clearer. This is a really stupid example. The much kind of more egregious example of how naming things can go wrong in Scala is symbolic operators, our favorites. Nowadays, after Scala's been around for, I think, 13 years at this point, and it's seen serious production use for the last 6 years or so. So this is known to be a bad idea nowadays. We've evolved enough as a community, we understand Scala code bases well enough to know that this is just a really, really bad idea, but it still sometimes happens. And I guess the question to ask is, why? What is to be gained here? So if you're in a specific domain with specific algebraic operators and properties that are well known, fine. Even then, I would argue that it doesn't make sense, but okay. But oftentimes, symbolic operators are just used in completely insane contexts. So if you've ever used dispatch, for instance, right? Dispatch, the HTTP client library, certainly the older versions of it really, really loved symbolic operators. So you have things like this and whatever. I can't read this. I wouldn't want to read this. It makes no sense at all. So just don't do that. On the other hand, you have Scala Z, which also it is kind of known that you shouldn't be writing code like this nowadays. But if you want your various categorical operators, you can have that in Scala Z. Just don't do that. It makes no sense at all. So just to kind of give you a quick example of how this would look like in a code base you have never run into before, let's switch to my favorite IDE, which is IntelliJ, and have a quick look at a bit of code. This is not the right window, so I'm going to switch to the window that went away. Sorry about that. All right. So we have here an open project for Scala Chess. It's worth noting, for those of you familiar with the library, this is actually a pretty old version of the library, so a lot of things had changed, and a lot of these things had been improved in the last couple of years. But one of the things that you deal with on a chessboard is the position of the various pieces on the board. So there is a class called pos, which kind of obviously stands for position. And it has, an x coordinate and a y coordinate. Can you actually see that reasonably well in the back? Okay, cool. You have your x and y coordinates, and then you have various, various functions that give you the cardinal directions away from whatever this position represents. That is not what I want to focus on. What I want to focus on is this part on the screen right here. There's a whole bunch of symbolic operators that just make it really, really hard to know what is going on. So I'm not gonna go over each of these because there's kind of not much of a point. But just to give you an idea of where this can go seriously wrong is you have this particular method, question mark lesser than. Now, if you're kind of, if you can make sense out of it, which is fairly easy, you can sort of have a look at this and see that these things represent a test, testing whether one position is on either direction from the other. So you have your question mark lesser than that tests whether the x coordinate for the position represented by this is lesser than some other position's x. Which begs the question, why even call it that? Why would you ever do that? Why not just call it is left off or whatever you're comfortable with, right? Why not just give it a name? It's not that much to type. It makes the code a lot simpler to read. Anyone coming into the code base can figure out what is left of means, whereas everyone else will have to actually go to the definition of these particular functions and try and figure out what they do. So don't do that. Right? This is just bad coding practice. Okay, any questions? This was just warm up. Now we're getting to hopefully more interesting bits. Cool. Right. So the actual meat of this particular presentation really revolves around kind of two themes, two subjects, or two common mistakes, if you will, anti-patterns. The first one is what is commonly called stringly typed. It's used to describe an implementation that needlessly relies on strings when programmer and refactor-friendly options are available. This is as good a definition as any. Fundamentally, what this means is you use a string where a different, more precise type will do. This is bad. So to give you a few examples before we kind of dig back into the source code. One example is passing unparsed data around. So maybe passing dates as strings. You have here a person class that has a name and a created kind of timestamp thing. And you may have you may have concurrent updates coming in from wherever, from your front end, for instance, and they might conflict. You have two conflicting updates, and you want to figure out which of the two updates happened first, so you can actually resolve the conflict. You'll notice that this, in distributed systems, this is probably a pretty bad idea, but ignore that for now. So we have a method called resolve conflict. It takes in two people, and it returns a person. And now it needs to parse the created timestamp for the first person and the created timestamp for the second person, compare the two, and decide which person object is more recent. Right? So this is pretty straightforward, but it's also very, very stupid, because you have three major issues. It means that wherever you actually want to kind of do anything with the timestamp, you need to know where the parsing code is. Right? And you might have 5 different time string parsers in your code base, and you might end up using the wrong one. Error handling is a problem because parsing can fail. And if parsing can fail, everywhere you need to parse, you need to do some error handling to make sure that a failed parse doesn't bring down your whole system. And it's also inefficient because you have to parse the thing over and over and over again. And there's a lot of boilerplate. So this is really just ugly code. If you want to solve this, the solution is kind of trivial. You just don't carry the unparsed data around. You just use the timestamp directly and parse it once, and you're good to go. A more kind of common thing, like timestamps people are kind of used to having date and time types in their class libraries. So this is not actually very common. But something like carrying location data around is actually very, very common. So it might be an address, and it might be a geolocation, it might be anything. Once again, you have a person class, it has a name, and it has this string location field. And you have your nearest neighbor kind of thing. It takes a person, and it takes a list of people, and it figures out which of the people is closest to your specific person that you're interested in. And once again, you have to parse the location, and for all neighbors, you also have to parse their location before you actually do the test. Once again, 3 issues. It's very inefficient, right? If your parsing is trivial, fine. If your parsing actually has to, for instance, go to some geo-IP database and resolve the location, then it's just wasteful. You're going to be doing it a number of times instead of just once. Once again, error handling is all over the place because you have to handle errors every single time you parse, and there's also a lot of boilerplate. Solution, trivial. Just don't carry the string around. Just use a point object or a geo object or whatever type you actually parse to, and just do the parsing once. And that's it. Everything is simpler now. You get much more efficient code. You have sane error handling semantics, and you don't get the boilerplate. It's just simple. One other very, very, very common thing to do is to use empty strings to represent like missing values. This actually happens all the time. I see this in practically every single code base I end up working on. The only worst thing you can do, and that is arguable, is to use nulls. So don't do either of these things. There is a very, very nice type in Scala. It's called option. You're all familiar with it. Just use it, right? It gives you the benefits of enforcing the emptiness check, and it's simple to use, and everyone knows it and understands it. Right, so that's just a quick overview of what this sort of problem is. Let's see how it might manifest once again in a real code base. Switching back to IntelliJ IDEA, to give you a bit of context on why is this stuck. Hold on a second while I convince IntelliJ to actually do what I want. Okay, so a chess game, as you might know, is basically a series of steps. Right? And typically, a chess game would begin with one of a series of well-defined sequences of steps known as an opening in a chess game. And there is a lot of research around this. Like it's still a very kind of actively researched game. One of the things you have is like a very, very large set, by which I mean about 3,000 of kind of well-known openings for a chess game. And an opening is represented by, in this case, we have our object called openingDB. It's a lazy val, which is just a list of openings. And an opening comprises of a code, right? If we look at the parameters, we have a code like B03. We have a name, which is, for instance, Alechin defense, the Balog variation. I'm probably mispronouncing it terribly, but I don't care. And you have this list of moves that is, some string representation of the moves made by the various actors in this particular chess opening. Right, so this is pretty straightforward. But if we actually look at the opening class, we have here a case class opening. It takes in those three parameters. So we have the code, we have the name, and we have the moves. Now this is really, really bad. And the reason this is bad is because it carries unparsed data around. So because it's a case class, all of the constructor parameters are exposed as public members to users of this class. So users of this class as a first class concept see this string representation of a move list as a member, right? Which is just irrelevant, right? No piece of logic in your code base will ever care about what the serialized move list looks like, unless it deals specifically with serializing or deserializing move lists. In fact, it's so obviously bad that there is a member here called move list, which takes in that string representation and parses it. Right? So this is just, it's bad, right? If you have any opening anywhere, so let me just give you an example. Let's say I have, an opening with some code, with some name, and some move list. And I use an IDE because I like IDEs, they're convenient. And I show what are the different, what can I do with this thing? What are the different members? What can I access? I see the code, I see the move list, I also see moves, right? I have these two things that mean the exact same thing, except one has a useful type and one is just confusing. Right, so this is bad. Let's get rid of it. What we're actually interested in here is instead of having instead of having the case class constructor take in a serialized list of moves, we actually want to lift the move list into a first class member or first class concept within the opening class. So I'm gonna make it a parameter called move list, which is a list of string. Now, string is not a good representative type for a move in a chess game, but we have only just started looking at this code base. We still don't know, what it contains, what are the different types, what are the different features. So let's just keep it simple for now and say, okay, we know the original move list is just a list of strings. Let's stick with that. And instead of having that as a constructor parameter and having this helper move list member, what we will do is we will just add a companion object that I'm going to try and focus on a little bit. We add a companion object, and we'll just add a parse method, which makes it very, very, very obvious what the intention is. Right? This is a trivial change from a syntactic standpoint, but it just makes everything a lot more easy to reason about for people. So it takes in a code, and it takes in, a name, and it takes in the list of moves as a string, and it returns an opening. So it calls the constructor, and we can use another very nice Scala feature that sometimes is very useful for making things easier to understand and cleaner. And we'll use named parameters. So we have, for now, code equals code, name equals name, and move list equals we can just copy paste the parsing code from above and get rid of this member. And at this point, we have a slightly cleaner representation of an opening. And there's probably some more stuff we can do, but we'll get to that as we need it. To kind of finish up this example, right now this will not compile because I just changed the factory method for opening and added a parse method. So I'm just going to do a massive search replace, replacing all of the instances of opening with opening.parse. And just replace all, and I should be good to go. Now, obviously, when you're refactoring things, you want to have some measure of safety. You want to know that your changes hadn't, basically screwed up the whole code base. Luckily, Scala Chess actually has a not insignificant amount of test code that we can use, and therefore we will increase the font size, run SBT, which is the build tool used for Scala Chess, and see if it compiles and tests. Now, getting slightly ahead of myself, it's not gonna compile and test because there are things we need to fix first. But this is, this is a good opportunity to see what kind of effect our changes had. So it's resolving, it's updating, it's doing a bunch of things we don't really care about. And it's gonna finish any minute now. All right, and then we just run test. And it's resolving again, I don't know why. And it's compiling everything, and in about half a minute or less, we should be able to see that the code fails to compile because probably someone used the opening class in a way that we did not anticipate, and therefore it screwed up in some way or other. I am not taking responsibility for these compilation warnings, by the way. This is not my code base. So, compiling some more, and we all know and love Scala 2.11's compile times. It's a little bit better in 2.12, by the way. We have some warnings, and we'll just let it run while I make sure that there are no questions or confusion so far. Anyone? Comments, questions? All right.
Didn't you just change perhaps introduce a regression because the opening database will now contain like thousands of new strings, or previously it was a lazily value?
So the question is, then maybe I've introduced a regression because the opening class previously had kept the string around and had the lazy val for the move list, and now I switched. Actually, it's probably going to be this should not have compiled. We'll look at this in a second. It's probably actually going to be the other way around because what generally happens is the string takes up probably about as much space as the list of moves. Not exactly the same, but about the same. And I'm not carrying the strings around anymore.
You are carrying because the class contains the strings embedded as static resources inside the class.
Oh, yeah. Well, the openings DB itself, well, it can. Yeah, but let's ignore that for now. Like we can. The reason I'm ignoring it is because this is not likely to be the thing that is going to harm you. If you run out of memory because you have too many string constants, or because you actually keep the the strings around as in turn strings in your constant pool, that is probably not going to be your biggest challenge. So the reason I'm surprised is I suspect I actually have some leftovers from my kind of previous experiments on this code base. So let's just make sure I don't have any. Yes, I do. All right, so I'm going to revert everything except the openings DB. No, I'm not going to do that. This is a stupid thing to get hung up on, but it's pretty trivial to fix. So let's just make sure I actually show you everything there is to show. So once again, it's opened the wrong window. Let's switch back. And I'm going to have to do this modification again, so I'll just make it really, really, really quickly, and I apologize for that. Should have seen that coming. This will take approximately half a minute. Yes, sorry. This is what happens when you're in a rush. So we also need to, I already did the search replace. And now actually if I go back to SBT and I retest, I should get a couple of compilation errors, which we'll see in a minute. So this is actually a good kind of entry point into our refactoring process. And why did it just fail to compile anything? Okay, while it's running, I will get ahead of myself and actually show you the thing that that would have failed to compile. So in my openings class, if I let IntelliJ actually do its thing and do the static analysis, you will notice in a few seconds that it shows these. It would have shown these red lines at the bottom. What is going on here? Yeah, this should not compile at all. All right. We'll see what SBT has to say about it. We have a what I consider to be an anti-pattern in the openings class, which is this. We have a number of these in the code base. And you'll notice that what it does is it pattern matches on an opening and it deconstructs the opening class into its constituent parts to do something. Now this is a reasonable thing to do in a lot of cases, but I think in this case what it does is it actually takes in an opening and it extracts a bunch of stuff, and it doesn't do anything kind of more interesting than that. So that's pretty bad. Right? We have here the code and the name and the move list, and we don't really care about the move list, but we're still deconstructing the opening class with a pattern match. Now, where this can fail is, for instance, if I go back to the opening class and I have a look at it, and one of the things I can see is, once again, another instance of carrying unparsed data around. You will see that I have the name field. But actually, I parse it into at least two parts. I have the full name, and then I have this family name of the opening, which, just to quickly showcase an example of that, for this very first defined opening, I have allocating defense, balog variation. Everything left of the comma is the family name of the opening. And I have a lot of these. I have actually, a few dozen of these. And codes also can repeat. So this weird notion of carrying the full name around but parsing it every single time I want to access the family name is just ridiculous, right? It's another form of parsing. I don't want that. What I want is to represent it as, once again, a first-class concept in my opening class. just to do a little bit of cleanup and remove this member right here. And we'll shunt it back to our parsing code. Okay, so this is cleaned up our domain object just a tiny bit more. The idea here is to get as tight as possible, is to clean up your API as much as possible so that your domain objects actually represent the least amount of information that is necessary for everything to work without carrying unparsed data around. And this actually will break because when deconstructing the opening, we know we need the code and the name, but now we actually have another thing. We have the family name. So we can fix it in one of two ways. The first way is we can just add another underscore because we don't care about that extra member. I actually think this is not a very good idea. Unless you're actually doing a pattern match, unless you actually have a number of cases and you're just extracting stuff from the object, just take in the object and use it directly, right? We'll have opening.name and we have opening.code, and we once again have IntelliJ being stuck on us, but I'll add it in a second. Once again, we'll have opening.code, assuming it's going to let me actually do anything. And this just cleans up the code, right? There's no pattern match, there's nothing. And also, if we look at the code again, we can see that there's actually code duplication here. We have on the above line, and I may have to restart IntelliJ because it's not handling this very nicely at all. Right, this line here does the exact same parsing that the class originally did, right? The class member had. So it's completely unnecessary. Let's just get rid of it. And once again, our code has become shorter and cleaner and easier to understand, and we don't do an unnecessary pattern match. And once again, for some reason, IntelliJ just decided it doesn't like me anymore. Family name. So while I kill IntelliJ and rerun it, and hopefully we won't have to deal with this again during the course of this talk, I will actually run the SBT base build. Okay, now I think my computer got totally stuck. I'll once again run the SBT build so we can see if there are any other kind of regressions that we've just introduced to the code base, and then we can move on to more interesting stuff. I apologize for the delays. This is what happens when things just go wrong, when you do live coding, basically. All right, so we'll reopen this. This is a quick and dirty kind of refactoring to just clean up the domain model a little bit, and that just makes using it in subsequent steps, like subsequent development, just easier. Because suddenly you don't need to worry about the difference between moves and move list. And you don't have the performance and possibly error handling ramifications of having the family name as a parsing method. Now let's take a look at a kind of more serious issue with Scala code. And this is, I think, the more common and egregious issue that you will run into. I call this collective abuse. Scala is a very, very, very nice and full-featured collections library. It's not without issues, but it's basically a very strong suite of features, which used to be one of Scala's killer features in earlier days. There's also a lot of built-in features in language. You might have case classes, you might have functions and tuples, which means that it's pretty easy to abuse. So two common anti-patterns with using the collections framework. Here we have an artificial bit of code. We have here a list of actors. This tuple represents an ID for the actor. That's the int field, the name of the actor, and a popularity score for the actor. And this is actually a very common thing to do if you're too lazy to set up an actual type. We have a function that takes in a query and returns the best actor matching that query. And it's kind of hard to read, right? It's kind of hard to figure out what it does. There's actors.filter, .sort by, .map, .head option. It's not very clear what the flow of data is and what things are actually going on under the hood when you execute this function. So, what does this even do? And this is actually a pretty simple example. So there's basically one very simple thing you can do in order to solve this sort of problem, and that is just name intermediate steps. Right? This is the exact same code. The only difference is instead of pipelining one operation after another, I grouped them together into sensible semantics and just gave it a name. So we have the same filter, and that returns matching actors. We take the matching actors, we sort them somehow, and we return the head if we have it, and that's the best actor by score. And then we map that into its ID, right? So this really trivial change, hopefully, just makes the code a lot more readable. It makes the intent clearer. Now, the second thing that is wrong with it is all these underscores. Because we have, what is it, 1, 2, 3, 4, 5. We have 6 underscores in this one function, right? And underscores are not necessarily a bad thing, but between the underscores and the indirections into underscore 2s, underscore 1s, all that stuff, it's just really, really hard to read. So, the solution in Scala, because types are so easy and available and cheap, just create a case class. It's one line. Just give the parts a name, right? Now I have an actor. An actor has an ID, a name, and a score, and suddenly the exact same code just reads perfectly reasonably, right? I have the actors list. I filter it to find actors where the name contains the query. I sort it by score in descending order. I map it to the ID, and I take in the head option. That is almost trivial to read. Right, so between these two techniques, you can kind of generally break apart any crazy collection abuse that you might run into. So let's take a look at a very, very, very egregious example from the same code base and even the same class, actually, as soon as I actually open it. Right. Let me just switch to presentation mode again. Right. We have in our openings class, and once again, everything is stuck. I think it might have had something to do with QuickTime trying to record things on the fly. Right. Let's focus on this particularly bad example of abusing the collections framework. We have here a lazy val called code family that takes in a map from string, that returns a map of string to string. Now, the types here tell us that whatever this thing is, because we don't have enough context to know what it's supposed to do yet, whatever this thing is, it probably maps a code, like an opening code, to its family in some way or other, because that's what the name and the types imply. But this is actually really, really, really hard to read, right? This is a lot of code. So the first thing we need to do is we need to tease it apart, right? There's too much stuff going on here. We're not going to be able to understand it as a whole. A very simple trick, just separate the two so you can focus on what's in the middle. Now, what this does is it takes the opening database and it folds on it. And it folds, it takes an empty map from string to a list of string, and it does something with it. Now, for some reason, our changes from before weren't saved because I don't know what the hell is going on. So let's just reintroduce them. Okay, we have our slightly simplified version of the same code from before. And now we can start trying to figure out what is going on here. So I'm assuming everyone at least has a decent idea what a fold is. We have our accumulator, and then we get an element in on every iteration. and we add to the accumulator something that maps the code to its family name plus, evidently, if we look at this, whatever was already part of the map for that particular code before. So we're basically generating a multi-map. We're mapping all of the codes to all of the family names that match that code in the database. I don't know that there's necessarily much we can do to simplify this code, so let's just add a comment saying maps codes to their respective families. Okay, just to help us make a little bit of sense out of it. And we can actually do better than that and just, code to family map. Just give it a name and just use that. Right, this is already a little bit simpler because suddenly this huge piece of code just makes a little bit more sense. Now we have this flat map here with a whole bunch of stuff, and we need to try and understand what this thing does and then figure out how to simplify it. So for each code and its associated set of families, we take in the families, group them by identity, and then map all of the values to the size. Now, this is actually a pretty common pattern in working with Scala collections, but if you have not run into this, what this does is it basically takes a mapping, say, B03 to, to an array of family 1, family 2, family 3, etc. Sorry. It takes this array of families, and what it does is it counts each family, it maps each family to all of its various instances. So if you have this array, the result of that, of the group by and map values would be a map of family 1 to all of its instances. In this case, we only have one, family 1. But family 1 shows up twice in this example. So you'd have an array of size 2 with just instances of the same string. And then family 2 would map to only one instance, family 3 to only one instance, and so forth. And mapping by value means that you replace all of these with just the number of instances. So you'd have family 1 showing up twice, family 2 showing up once, etc. So you can give it a name. We can, very simply just add a function that gives us the expression normally used is cardinality. So we take in a list of string, and we return a map from every distinct value to how many times it actually shows up in the list. Group by identity, map values to its size. And then we can start simplifying things. Now we have a slightly better idea of what's going on here. And just to wrap this up, we have here a toList and sort by the second element in that list. We know that the second element in the list is the number of instances of a particular family. And then we take in the head option. So all of this actually translates to, for every code, select the family that has the most instances, or the best family. So let's just give it a name. Best family takes in a map from string to int, and this is probably where we'll finish because we're pretty much out of time. And it returns just the best family, which is the map to list, sort by the right-hand element, which is the size, and give me the head option.
Minus second element.
Yes, and also it should be an option of a string. And if I can have one more minute, or maybe not.
It's up to your speaker right after you. So.
Sorry?
The time is out because we're out of time, so sorry. Look, it's like
all right.
It's been 45 minutes, so.
Okay, sorry. So we had a few too many delays, but the idea here is you tease it apart, right? You take parts, you figure out what they do, you give them a name, you start reconstructing the pipeline together, and you end up with code that is just simpler and easier to read. And then someone coming into your code base, instead of seeing this 8-line pipeline of operations on a collection actually has a sensible list of semantic operations that happen on those collections, and they can actually reason about your code. So I apologize for the technical difficulties, and that I wish I had a few more minutes. Thank you very much, and if you have any questions or you want to see more stuff, come talk to me later. Cheers.
Yeah.